right, this is section 10.2, part 4. And again, we've covered our first two concepts in previous videos. Now we're just looking at another example of testing a hypothesis for a proportion, for a population proportion. All right, so here's our example, and again, there's lots of words here, and I know I've said this over and over again and probably sound like a broken record, but statistics is really less of math and more of reading comprehension. So please keep that in mind as you're reading through these problems. This is not one of those just skim for all the numbers you can find and then they'll probably fit somewhere. You might get lucky and that might work for a problem or two, but it's not going to work every single time because sometimes numbers are spelled out as words, or sometimes there are numbers that are extra that don't necessarily have anything at all to do with the hypothesis test, but they have to do with the population that was chosen. So keep that in mind. Actually read through the problem, the entire problem, and look for those keywords and key things that we need for a hypothesis test. All right, so in this problem, we've got that we're going to suppose that the proportion of registered voters who are registered Republicans in a certain congressional district is 0.42, so 42%. After the census and redistricting United States congressional districts in Illinois, members of the Republican National Committee wonder if the proportion of Republicans in this district is now less than 0.42. In a random sample of 60 registered voters in the district, it's found that 22 are registered Republicans. Do the results of this survey suggest that redistricting resulted in a lower proportion of registered Republicans in the district? All right, so we've got several things that we want to be sure we register, no pun intended with registering voters, but we want to stick in our head. So first of all, of course, we've got the word proportion in here, so we want to keep that in mind. We're dealing with a proportion, and if we're dealing with a hypothesis test, then we're likely going to use a one-prop z-test. The other thing is that we know what it should have been. Here's what it was. We want to know, is it now less than that value? So there are our hypotheses, the null and alternative hypothesis, and then we have our data. All right, so let's take a look. All right, so again, we want to start off by checking our conditions to make sure that we're going to be able to run our hypothesis test using one-prop z-test. And so our first thing is to make sure that this is a simple random sample. It does say that in a random sample of 60 registered voters, so we're good to go there. We want to check our sample size times the parameter times 1 minus the parameter. We want to make sure that that's greater than or equal to 10. And so that's going to be 60 registered voters. And then we had our previously known value was 42% or 0.42. And then, would you look at that? 0.58. So we actually have the same, this is kind of just the opposite. That's interesting. I didn't realize that until just now, that this is the complement to the percentage that we had in our previous video of 58%. So we're actually dealing with the same two values there. But now we're multiplying by 60 instead of 500. So we're going to go in and we're going to say 60 times 0.42 times 0.58. And, oh, I did 6. That's not right. So I can multiply by 10, and I should be okay. There we go. And this is a lot closer, but it's still bigger, so that's okay. We wanted this to be greater than or equal to 10. It is 14.616. Well, that is still greater than or equal to 10. Previously, we had 121. Doesn't matter how much bigger it is, it just needs to be bigger than 10. So as long as it's 10 or more, we're good. And then as far as it being independent, again, our sample size is very small. And I don't think we even need to double check, but we will, because we're not dealing with all of the United States now. We're dealing with we're dealing with one congressional district in a state. So if we just want to make sure, as long as our population is bigger, and again, I'm just dividing by 0.005, as long as we have more than 1,200 in our population, then we should be good. And I gotta say, for an entire congressional district, that's very likely that there are more than 1,200 people in there. So I think all of our conditions are met. We're ready to move on. All right, so I've pulled out our important pieces that we talked about on the previous page when we had our entire problem written out. We were told that before the census, the proportion of registered Republicans was 0.42. They did a sample of 60 people, got that 22 of them were registered Republicans, and now we're wondering if it is less than 42%. Notice that we were not given a significance level, and sometimes that happens. And when that happens, a lot of times, at least in this class, you can just be safe and say 0.05, like we were doing before we knew to call it a significance level. And so we're going to assume that we need to test this at a 5% level of significance. All right, so I want to come up with my null and alternative hypotheses. Oh, I dotted my 1. That's not right. Hi. No, there we go. So my null hypothesis, again, I'm dealing with proportions. So if I need to, I've got this as a key word in there to help me remember that I'm dealing with proportions, which means my parameter will be p. That's going to be true in both my null and alternative hypotheses. I'm also going to always, always, always have equal in my null hypothesis. So p equals what we knew it to be before, 0.42. I am wanting to know, very specifically, if it is now less than that. So there's my alternative hypothesis. That's what I'm looking for. I'm looking for evidence to show that I have something less than 42%. Now, if 22 out of 60 was more than 42%, I wouldn't even have to run a hypothesis test. So that's always a good thing to check. If you feel like you might have something that's more than 42, then we wouldn't have a reason to believe that it's less. Like, that'd be enough. Oh, well, we got a sample that was well above 42%, or even just a little above 42%. I can promise you that will never give you the evidence you need to say that it's less. If you have a number greater than the parameter that you're starting with, and you're trying to find evidence that it's less, that will not work. So there are my null and alternative hypotheses. Of course, I'm going to use the one prop z-test. I checked all my conditions, and they're all fine. This is going to be a one-tail test, since I'm looking only for evidence that is less than. And I am going to assume, even though it didn't tell me to, that I have a significance level of 5%, or alpha equals 0.05. All right, so let's see how our calculator comes into play, and then we'll make a decision, write a conclusion, and be done with this video. All right, so we are going to use our calculators to test this hypothesis. We're going to go to our one prop z int, again, because we're doing a proportion. Of course, we've got my old data in here, so we've got to change everything out, but my null hypothesis is going to be that p equals 0.42. I've got to put in my new x and n. So we had x was 22, n was 60, and then I've got to change my alternative hypothesis. So notice here I can move over using the arrow key, but if I just stay there, I'm not going to select it. I must hit enter to select. So when you go down to calculate, if it's not still highlighted with that less than P naught, then I haven't actually selected it. Okay, so again, I've got my values. Let me get rid of that. I have my alternative hypothesis just to check, make sure I can remember. Yes, I did test that my proportion was less than 0.42. So again, remember, this should always match up with our alternative hypothesis. That's our calculator letting us know, hey, this is what you told me to do, so here's the information I got. If that doesn't match up, then something's wrong. All right, and then we can see that we got our test statistic. So again, when we see this, it's going to always, it'll have z equals, and then it'll have your box for you to fill in. And we'll always ask you to round this to 2 decimal places. So this is negative 0.84. Now, we didn't talk about this in the last video. I kind of just skimmed over it because we're not really using the test statistic or critical value method in this. But what this is this, remember, a z-score tells me how many standard deviations away from the mean am I. I am below the mean, that's the negative, but I'm not even 1 standard deviation below the mean. So this is not very convincing evidence, which is what our p-value is also going to tell us. We'll always end up with the same decision, regardless of which method we use. I just like to focus on the p-value method. So our p-value is given next, and it is 0.201. Usually, again, that's going to ask you to round to 3 decimal places. It gives us our p-hat. Now, this p-hat is actually quite a bit less than 0.42. So this 0.36, where that 6 repeats, this is about 36%, almost 37%. So that has dropped, but because our sample size was so low, I mean, we only had 60 people, this didn't end up being significant enough. If we had had 600 people and 222 of them, or whatever it would end up being, that would give me that same exact proportion, then that would be a different story. That might end up being significant, but with only 60 people, this did not end up being a significant enough sample. And so I'm going to look at my p-value versus my alpha. And so my p-value was 0.201, and I'm comparing that to 0.05. And again, if you want to throw that extra 0 on there, so you're looking at 2 3-digit numbers, that's fine. But in this case, 201 is definitely greater than 50. So that is not enough, not unusual. So we're going to fail to reject the null. This is not enough evidence for me to believe that that proportion is changed. This is just a sample. We know samples vary. That's another one that I feel like I'm on a repeated record for. Samples vary, so this is just a sample that happens to be lower, but not low enough for us to change our mind. All right, so for our final conclusion, we're going to write that conclusion out. We're going to say there is insufficient evidence so basically, our sample was not extreme enough to give us the evidence needed. So there's insufficient evidence at the 5% level of significance to suggest, and now we want to reference our actual problem, that, let's see, to suggest that the proportion of registered Republicans is now less than 0.42. And there we go.